Let's see another problem. There is a fifth problem on strength of material. A tensile test is performed on a brass specimen 10 mm diameter using a gauge length of 50 mm. When applying axial tensile load of 25 kilonewton, it was observed that the distance between the gauge marks increased by 0.152 mm. Calculate the modulus of elasticity of brass. So this problem is different from the previous problem. Here you already performed the tensile test. I think in the fourth semester you will perform, or sorry, in this third semester only you have got the tensile test. You are taking the tensile test specimen. So this tensile test is performed to calculate stress, strain, Young's modulus, elastic limit, and um, ultimate load, ultimate failure point, and final fracture. I explained this in the ductile curve of the mild steel. Here, what they given, the tensile test is performed in the UTM machine. So what specimen they taken? They taken the brass of 10 mm diameter. They are taken 10 mm diameter using a gauge length of 50 mm. Gauge length means they are marking 2 point. So this length they are taking 50 mm. They are applying the axial load. They are applying the axial load of how much? 25 kilo Newton. 25 kilo Newton. It was observed that the distance between the gauge marks increased by 0.152. When you are applying the load here, so the specimen is like this. The specimen is like this. This is understood in the MT lab. So this diameter is almost 10 mm. So okay. So when you are applying the load, so that time the it will increase it by means 50. It becomes 50 point how much 152. They are given 0.152. So up to 0.152. Calculate the modulus of elasticity of the brass. So you need to calculate here modulus of elasticity of the bar. So first of all, write the formula. What is the modulus of elasticity? Young's modulus and modulus of elasticity both are same. Young's modulus is equal to stress is directly proportional to strain. So this you have to remember. So now what are the data you need to find? They are not given the stress, they are not given the strain. You need to find the stress. To find the stress, you need to write the data what they are given. So first they are given the load. Load is how much? 25 kilonewton. So 25 kilonewton, 1 second. Kilo, it becomes 10 raised to 3 because 1 kilo is equal to 1000 gram. So 1000 means what? 10 raised to 3. So like this, you always concentrate properly on the units, because if units get wrong, whole problem will be wrong. Okay. Now let's see what is the formula of stress. Load upon area. So load upon area, what is the load? 25 into 10 to 3. This is a very simple problem. Area 5 by 4 into d square. So d, they are given, what is the d? 10 mm. So d is equal to 10 mm. So you put here 5 by 4 into d square. Okay. It becomes, stresses becomes 318.34. So what is the unit of stress? Newton per mm square. 318.30 Newton per mm square. What is this? This is the stress. Sigma is equal to, because this unit also is very important. In exam, most of the students, they will not write the unit. So don't forget to write the unit. Is very important. Now we calculate strain. What is the strain? Strain is equal to E. E is the notation of the strain. What is the strain? Change in length upon original length. Okay, I'll write here. Change in length upon original length. Change in length is how much? 0.152. What is 0.152? When you are applying the load, while you applying the load, there is a increase of, before it was 50 mm, so it is increased to 50.152. This is the change in length. Okay, so 0.152, don't take 50.152, so only take what is the extension 0.152 mm. You need, if it is in meter, you need to convert into mm one second. It is given already in mm, no need to convert. 0.152 and length is 50 mm. So you have got strain. Okay, now next point is Young's modulus. What is Young's modulus? Young's modulus is equal to stress sigma. Stress is divided by small e. In some book they are given this stress in the other notation. We take sigma divided by e, small e. So what is the sigma? Stress already you have calculated, where 318.30. okay, you take this here and divided by this strain. Okay, so you calculate it with the help of bracket you put always, and you need to get the same answer. So like this you practice the two problems today. So I will send the two problems as well as the two problems you need to practice it, and you need to send to email address. Okay, so with these two problems you make it perfect today, and in the tomorrow class I will continue the next video. Okay, thank you very much.